Hello, in this project we will learn to interface a stepper motor with Tiva Launchpad. We have to synchronize its motion such that it completes its rotation in 60 seconds and its rotation will be shown on LCD. Our components are the current required to drive coils by applying a sequence of control signals is almost 200 milliampere. GPIO pins of Tiva Launchpad cannot provide current of its magnitude. Therefore, we need a ULN 2003 driver which translates low current output of Tiva GPIO pins into higher current that meets the requirement of stepper motor control signal. We will power it with external 5-volt supply. The following figure shows the Pinout diagram of stepper motor. It consists of 5 pins. Out of these 5 pins, 4 pins are used to provide sequence logic to the coils and 1 pin is plus 5-volt supply pin.
First of all, I'll include TM4C123 library that is basically included due to the registers I have used further. After that, I'll write the different prototypes, basically LCD write initialization, LCD write data, LCD write command, LCD port initialization, LCD clear, LCD write string. These prototypes are included. After that, I'll initialize different variables which I use further. I equals 0, for example j equals 0, time equals 0, revolution, buff character, b character. The function that are made after the main functions, their prototype should be written on the top. So after that, I'll discuss about the main function. In main function, we'll unlock the port F. For unlocking the port F, we will give it the clock 0x20 as it shows on the screen. SYSCTL RCGC2R equals 0x20. The above 3 semicolons shows the delay. After the delay, we'll unlock the port, basically port F. So we use GPIO lock key. After unlocking the port, we will move to unlock its pins. GPIO port FCRR is used to unlock the pins of port F. As we do not use any selective function, so the value of GPIO port F AF SELR is equal. After that, GPIO port F digital enable, which is equal to 0x0F. It means that GPIO data pins PF0, PF1, PF2 and PF3 are digital pins. After that, we'll write GPIO port F direction register, whose value is also 0x0F, which means PF0, PF1, PF2 and PF3 are used as output. After that, we'll call the different function. We will call the functions that we made after the main function. It's basically the function we used in the main function that we made earlier, named as LCD port init, LCD initialization, LCD clear function. After that, we move towards the for loop. First for loop is running infinitely as I equals 0 and I greater than equal 0 and I plus plus. So the loop works when the value of I is greater than 0, as I plus plus means the value of I is increasing after every. This I plus plus means as the loop runs one time, the value of I is increases one time. So for the first time the value of I is 0. For next for loop the value of I is 1. For further next loop the value of I will be 2. So this loop is running infinitely. After that, we will use the nested for loop for the time, as there is 60 seconds in a minute. So the value of j is less than 60 and it starts from 0. It means this loop runs 60 times. As this loop runs 60 times, the revolution plus plus means revolution increases. Basically, as the motor rotates as the motor completes its one revolution, it indicates the needle of the clock which moves 60 steps to complete 1 minute. So this 1 minute indicates using the for loop whose value is less than j less than 60. So as this for loop works 60 times, that hour will be 1 minute. After the running of for loop 60 times, for displaying this time on LCD screen on the top row we use 0x80. For the second row we use 0xC0. Further, LCD write command is used to write it on the screen. Buff is basically the character we initialized. Buff is basically the character we use to store the number as a string in it, as it is shown on the screen. As the time passes 60 seconds, the value of revolution changes from 0 to 1. Then we'll write LCD clear function that will clear the screen and move the cursor to home screen. After that, there is a for loop of the steps of motor to complete its one revolution. Basically, our stepper motor completes its one revolution in 250 steps. As we use full drive clockwise rotation sequence, so the value of port F data R is first 0x08, then after the delay of 30 milliseconds its value is 0x04, then after a 30 millisecond delay its value is 0x02, then further 30 millisecond delay its value is 0xB01, which is seen which we write with the help of truth table. After that, I'll write the delay function. As we studied in our daily classes, the delay function, so there is no need to explain this function. Basically, there are two for loops, two nested for loops which are used First for loop is the loop of time in millisecond. Similarly, working with the second for loop, we will make the delay function. After that, there is a function of LCD port initialization. In this port initialization, we will enable port F. In the LCD port initialization, we will enable port B and port A. We will basically unlock the port B and port A. For enabling clock to port B and port A, the value of sysdig control RCGC2 is equal to 0x03, and again these three semicolons are due to the delay. For unlocking port B, we use GPIO lock key as I used earlier. Then for unlocking its pins, we use GPIO port B CRR, whose values is 0xFF, which means we will unlock all of its pins. As there is no selective function here, so its value of GPIO port BAF SCL is also 0x0. For digital enabling, as we are enabling all of its pins, so its value is 0xFF. Further, GPIO port B direction, it indicates the pins that are used as output. So as we use all the pins of port B, so we will write 0xFF. After that, I'll unlock port A. For unlocking port A, the procedure is same. After that, I'll make LCD write command function. LCD write command function includes GPIO port A data are equal 0x00, which means that the value of register select is 0. Basically, PF5 is register select pin, PF6 is read write pin, and PF7 is enable pin. For LCD write data function, the value of RS is 1, so that we will write GPIO port A data R is equal to 0x20. For LCD write command functions are used for LCD initialization. After that, I'll make the function of LCD clear, where the same LCD write command is used. Two LCD write command functions are used for LCD clear. One will basically clear the screen, and the second 0x02 is move the cursor to home screen. After that, I'll make our last function, LCD write string function, whose input is character pointer. It includes the while loop and LCD write data function. For example, we have a string of 10 characters. As the input of LCD write string is 8, and then this function means basically this function write the string up to 8 characters. So that by using these all function, I'll make the rotation of motor is in such a way that it completes its one revolution in 60 seconds and displayed the time and revolution on screen.
So our first task is to configure SysTick timer to generate interrupt after 1 millisecond. First of all, we will include the library TM4C123 GH6PM.h. It is included as we use the registers. So first of all, hashtag define STAN0x01. It means we have to enable SysTick timer. After that, we'll do hashtag define int EN0x02. It means that we will enable the interrupt. Then further, hashtag define CLK SRC0x04. It means that we will enable clock source. Basically, these three steps are the basic steps. After that, I'll describe the different prototypes. For task 1, the prototype we use is SysTick enable interrupts, disable interrupts, and port initialize. I'll discuss task 3 as well. So for this, we'll use port F initialize and Uart initialize. Uart enable. These are the prototypes discussed here. Their functions are made after the main function. So now we'll discuss the main function. In main function, first of all, we will disable interrupts. After disabling interrupts, we will call SysTick enable function. Then we will call Uart enable function. After that, we will call port initialize and while one. These are the functions that are made below after the main function. So we will discuss these functions now. So as our task is to create an interrupt after 1 millisecond, so now we have void SysTick enable function. So it starts from NVICST CTRL control register and its end with negation 0x01. It is basically reset that bit. So the control register if the control register have any garbage value, then it will be cleared. After that, NVICST current R register equals 0. Basically our SysTick timer is down counter, so it ends at 0. So that's why control register has 0 value. After that, there is SysTick timer reload register. Reload register has value with respect to our timer. We have generated interrupt at every 1 millisecond. After every 1 millisecond. So for 1 millisecond, the frequency of Tiva is 16 megahertz. As we multiply the time and frequency, we get 16,000. So the value in reload register is 16,000 minus 1 because it starts from 0. So the value in reload register will be 15,999. After that, we will write NVIC CTRL basically in control register. Now we will add all the three values, that is value of SysTick enable, interrupt enable, and clock source. Basically the first bit is SysTick enable bit, and the second bit is interrupt enable bit, and the third bit is clock source bit. So all these bits are set 1, so we will get 0x07. So by using these functions, we will generate the interrupt after 1 millisecond as it is called in main function, and after that we will call enable interrupt. So task 1 is completed. Now we will move to task 3, which is related to Uart. So first of all, I'll enable the port initialization. So the function port F initialization. In this function, first of we will give the clock to port F as we enable port F. After enabling port, I will give the delay. These three semicolons shows the delay. After delay, I'll unlock the port. After unlocking the port, I'll unlock the pins. The pins we needed, we will unlock these pins. As we have to use PF1, PF2 and PF3, so the value of port F, GPIO port F CRR is equal to 0x0E. Similarly, we will digitally enable these pins. For that, the value is equal to 0x0E as previously. After the digital enabling, we will give the direction. So the value of direction is also equal to 0x0E because direction will tell us the ports, the pins we will use as an output. So as we use these pin for output, so it will also equal to 0x0E. After that, we have to select a function. As we are using Uart, so the value of selective function, alternate selective function, is 0x03. That is basically port initialization. For the Uart, we will enable port A. So the value of digital enable is also equal to 0x03 as we use Uart 0 and Uart 1. Now we have to enable the Uart, so we have function for the enabling of Uart named as void Uart enable. First of all, we'll give it clock, that is Uart 0. We'll give the clock to Uart 0, then use 3 semicolon to give the delay. After that, I'll give clock to port A, that is enable the port A. After that, I'll give the delay using 3 semicolons. Basically, our task is configure Uart with 9600 baud rate, 2 stop bits and no parity. So first of all, we'll clear the control register. Then we will find the value of IBRD and FBRD, basic baud rate and floating baud rate. For that, we will use frequency of Tiva, that is 16 MHz divided by 16 into the value of baud rate, that is 9600. So we get 104.16666. So the value of IBRD is equal to 104 in decimal. For finding FBRD, we will multiply the fractional number to 2 raised to power 6, that is 64. Then we will move to next register, that is line control register. Line control register has 8 bits, whose first bit is break, second bit is parity enable, third bit is even parity enable, fourth bit is stop bit, fifth is FIFO enable, and then data bits, and then SPS bit. Break and SPS has always the value 0. As mentioned in question, there is no parity, so the value of parity bit and even parity bit is 0, and the FIFO enable is not mentioned, so the value of FIFO enable is also 0. Stop bit value is 1 if we have 2 stop bits. If we have 1 stop bit, then the value of stop bit is 0. So now we have the value of stop bit 1. Now at last, data bits. Data bits have value 00 if we have 5 data bits. If we have 6 data bits, then its value is 01. If we have 7 data bits, then its value is 10. If we have 8 data bits, then its value is 11.
After that, we'll move to next register. The name of next register is control register. The value of control register is in such a way that the 8th and 9th bit is transmitter and receiver, so the value of these bits is always 1, and the 0th bit is Uart 0, so we have to enable it, so its value is 1. By calculating, we will get 301, that is 0x301, that is, it is in hex value. The value of line control register is 0x78. After these calculation, we will call port initialization function. So in this way, task 1 and task 3 is completed.
Our second task is to define static handler routine count number of 1 millisecond elapsed. We have defined two integers int counter and int millisecond data type integers, and we have assigned the value 0. We have made a function static handler in which first counter is incremented, and we have applied if statement here in the counter is greater than equal to 1000. Then our second variable ms will incremented by 1000 and counter get again 0, and it will print number of milliseconds by Uart print num ms. This part we will discuss later in the code. Our last task is to define a routine function that prints working millisecond elapsed. Print, we have to define some function. First of all, we will define Uart send character, in which we are defining character type C. We are applying a condition while Uart flag register taking its end with 0x80, and if it is not equal to 0x80, we are sending Uart data is equal to character. 0x80 is the next function we are making is Uart print num. Let me tell you, is not print integers numbers, it only print character. Print, first we convert into ASCII values, then we will send it to the serial interface. First of all, we are declaring here is int I, unsigned 8 integer num60, unsigned count equal to 0, and applying a if condition. If n is equal to 0, then we are sending data register is equal to 0 and return. Again apply a while statement if n is greater than 0. Here again we are converting into ASCII value. We are dividing with taking remainder of the value and then adding 48 and incrementing in it. Portion is used for converting into ASCII values. In this loop we are taking the end of the flag register, sending the num I into data register. So here is the Uart print string. Here we are defining the pointer of point char. Now we can only send a character at a time. We have applied the while loop, so it will increment the value of the point unless the whole string is printed. Let's see the output. You can see that after 1000 milliseconds